And in the previous classes, we have discussed about Arduino, breadboard, LED, resistors, push button, LDR, digital write function, digital read, then variable name, if else, analog read, serial monitor. And in the previous class and the before that, we discussed about the battery operated motor. And in the previous class, we discussed about L293D motor driver. So one more thing is to be discussed before going to the before assembling a robot, and there is one sensor. And the sensor which we are about to discuss is the ultrasonic sensor. And this is the pictorial representation of this ultrasonic sensor. It operates with 5 volts and the operating current is 15 milliamps, and it operates at a frequency of 40 kilohertz, and the maximum range is 4 meters and the minimum range is 2 centimeters, and the measuring angle is 15 degrees. So here we may have 4 pins. This VCC where we have to give the 5 volt, and the fourth pin is the ground. That is, the first pin is the VCC, we have to give the 5 volt to this, and the fourth pin is ground. Other than this, we have 2 other pins, that is the second pin and the third pin. The second pin is the trigger, and the trigger pin should be treated as an output pin, and the echo pin or the third pin should be treated as an input pin. So let us go into the description or before of the circuit, description of the circuit. And the circuit which we are going to do is a ultrasonic sensor which reads some values or the distance between an obstacle in front of it, and based upon that it will make to blink an RGB LED. Here today we are using the RGB LED. Here we can have 3 colors, red, green and blue. Of this we will be using red and green, and blue is left blank. So this is the circuit for that, and this is the red terminal, and this is the cathode connected to the ground, and this is the blue, we have left the blue free, and this is the green which is connected to a resistor to through a resistor to the Arduino board. So this is the circuit which we are going to simulate today. Okay, so this is the code. Before going to the code, let us see the connections also. This is the first pin connected to the VCC, that is the 5 volt, and this is the second pin which is connected to the 7th pin of our Arduino board. Second pin means the trigger pin, trigger, and the third pin which is the echo pin is connected to the 6th pin of our Arduino board. And this is the fourth pin which is connected to the ground. So let us go for the simulation. So let us take a new circuit. And let me rename this by the name Ultra Tri LED. Okay. And first thing to be taken is our Arduino board as well as the breadboard. And next we should find our ultrasonic sensor. So this is the one, but this has only 3 leads, but we want the one with 4 leads. So let us search here all components. Yes, ultrasonic distance sensor. So if it is not filed for the first time, you change the components to all components and then take it. Here we have four leads, all VCC, trigger, echo, and ground. So connect this. Okay. Next we need an RGB LED. Yes, this is RGB LED. Okay. We have placed the RGB LED also, and we are in need of two resistors also. So I have to rotate this. Yes, and change the value also. And let me give us some 220 ohms or 330 ohms, whatever it may be. I am giving 220 ohms today. So this can also be of 220 ohms. So now we can start the connection. Yes. First I can connect the ground. So let us give the black color for the ground wire. And this is the 5 volts. Let us give red color. Okay. And next we have to connect this. This is the power or VCC. VCC should be connected to this the 5 volts, and which can give by the color code red. And this is the ground. The ground connected to the 0 volt or ground, and give the color code black. And now we have two other pins. That is the trigger and echo pin. So we have to connect this trigger to this pin number 7. Pin number 7. And let us give some orange color. And this is the echo pin connected to the pin number 6. So we connected this to the pin number 6. So all the 4 connections from the ultrasonic sensors are over. And now we have to, this is the ground or cathode of our tricolor LED or RGB LED. Connect this to the ground. Give the standard color code black. And what we aim is, if we are fixing some threshold distance, let us fix some 15 centimeters. If our object or the obstacle is within this 15 centimeters, our RGB LED should glow in red color. Otherwise, it should glow in a green color. So for that, we have to take 2 outputs from this Arduino board. Let us take it from pin number 8 and 9. So pin number 8, we give it to the red color LED through the resistor of 220 ohms. Yes. So let us green, yellow. And another one output from pin number 9. Yes. And you can give the purple color. Okay. So now our connections are somewhat over. So we have given all the connections. We have given, yes, and the blue is left free. Blue color is left free. No need of that blue color lead. So we have connected red to this through this resistor to this pin number 8, and 9th pin of the Arduino is connected to the green color lead of our RGB LED. As well as we have connected all the 4 terminals from the ultrasonic sensor also. So now we can go for the programming part. So we can take the program with code, blocks with code. So let us delete what is present there, the default things present in our programming window or the block area. And let us first define a variable. And we want to measure the distance. To measure the distance, let us define a new variable with the name distance. Okay. Yes. Now we have to set the distance. Now we have to set the distance. What is this distance? The distance is read by our ultrasonic sensor. So go to the input, that is the block. In the input block, you can see an thing that is the read ultrasonic sensor distance, and drag it and place it here to this 0. Okay, and you have to set something here. Read the ultras, that is the, it is the default thing. And the trigger pin, where will we connect our trigger pin? Trigger pin means this one. Trigger is connected to pin number 7, and this is the echo pin. Echo pin is connected to pin number 6. So trigger pin is pin number 7, and echo pin, this is pin number 6, and in unit centimeters. We are taking the measurements in centimeters. No need to change that. So distance, we are setting the distance to read from the ultrasonic sensor here. Actually, the distance is read from the ultrasonic sensor with trigger pin at pin number 7 and echo pin at pin number 6, and in units centimeters. So with this block, see here, automatically these things are generated. I will explain all those things at last. First, we can simulate this circuit. So all these 7 or 8 lines are generated with this one coding. And now we have set the distance. Once the distance is set, and we have to read this, based upon this distance, we have to set our output. So we are going for that. And for that we are using the control block. And today we are going to use if alone. So before that, we can add one thing. So we have to read the output at the serial monitor. So print this to the serial monitor. So print to the serial monitor. What we should print? The distance. So di distance is to space, and it should be displayed in a same line. So without new line. Again, one more output block. Print serial monitor. The thing to be printed is the distance. And here also there is no need of a new line. It should be printed in the same line. So without new line. And again, we should display that unit also. So for that, we can have one more block. Print to serial monitor. And here it should print centimeters. cm. So with a new line. After this, it should come to a new line. That's all. What we have done three things. That is, it will write in the serial monitor, distance is the value read from the ultrasonic sensor in centimeters. That's all. So now we can give the control units. So today we are using two if conditions. In the previous case, we used the if else, and today we are going to use if condition alone. And today we are checking two conditions. What if the distance is less than 15 centimeters, or if the distance is greater than 15 centimeters? So we are using two if blocks. And in both these cases, we are in need of this comparison, or from which is from the mathematical block. Yes, and this is the distance. If distance, yes, and if distance is less than or equal to 15 centimeters, less than or equal to 15 centimeters, then what should happen? The red LED should blink. The red LED should blink. So for that, set pin, and at the same time, the green LED should be in off state. So we should see where we have connected the red LED. We have connected this. This is the red lead, and this is connected to pin number 8. Pin number 8. So pin number 8 should be high. If distance is less than 15 centimeters, the pin number 8 should be high, and pin number 9 should be low. This is the condition. But at the same time, if the distance is greater than 15 centimeters, then the opposite thing should happen. That is, pin number 8 should be low, and pin number 9 should be high. So, and for this whole circuit, let us give a small delay, for a delay of 500 milliseconds. So this is all about our coding. We have declared a variable distance, and that we are storing the value which you have read from the ultrasonic sensor in that variable distance. And we are printing that distance on the serial monitor also. And by comparing that distance with respect in threshold value of 15, we have fixed the threshold value to be 15. If the distance is less than 15 or less than or equal to 15 centimeters, then the red LED is set with the 8th pin. 8th pin should go high and the 9th pin should go low. If the distance is greater than 15, that is the 8th pin should go low and the 9th pin should go high. That's our condition, and we have given a delay for this whole unit. So let us simulate this, and after that I will explain this code. Here it is now the green LED is blinking now. So let us see what is the distance. Here the distance is displayed at 113.4 centimeters. We can change this. See here, I am bringing it to below 15 centimeters. See here, it is now 12 centimeters. Now the LED color has changed to red color. So based upon the condition, based upon the distance measured, these LEDs changes. This is a color change of the LEDs based upon our program. Similarly, we can use this sensor to control the motion of some objects, some motion of our robot. And in the next class, we will be using this to measure the distance. It is actually measuring the distance. This is an obstacle in front of that. That is, this is the sensor and this is the obstacle. So it sends, this is the transmitter. It sends the ultrasonic waves. The ultrasonic wave gets reflected by the object in front of it, and it is received by the receiver based upon the time taken by the wave to reach back, and pulse is produced, and based upon that pulse the distance is calculated. And by measuring that distance, we have set our LEDs to blink in to glow in red or green. That is our condition. So see here, as the distance become the very low, 9 centimeters, it became red. So I am increasing. It became 16.8. It became green color. Okay. So this RGB LED should also be used with resistors, 220 ohms or 330 ohm resistor. It is vital. And now I will explain the codes. That is the okay. See here, this is the declaration part where we have declared a variable of integer type distance, and this is the setup part. It is not the setup part. This is the function. Once if we generate this read ultrasonic sensor distance block, this whole function will be generated. This whole function is related to the working of our ultrasonic sensor. That is, this takes the trigger pin as the output pin and echo pin as the input pin. So both these values are treated as integers. See here, pin mode, trigger pin as the output pin, and this is the echo pin. Echo pin is treated as the input pin. And initially we are giving an trigger pin as 0. At the initial condition, we are setting the trigger pin to 0, and within 2 microseconds delay, not milliseconds, 2 microseconds delay, we are giving a pulse to the trigger pin. Once it receives a pulse, and to trigger the sensor, the pulse should be at least of 10 millisecond time. So not 10 millisecond, 10 microseconds time. So once a 10 microsecond pulse is given, it will send an that is ultrasonic response in the air. So based upon that response, there is the our echo pin works. Once the there is the trigger signal is set, the transmitter transmits an signal, ultrasonic signal. Once it transmits that signal, our echo pin is made to high. Our echo pin is made to high, and it will receive the reflected or the echo back. And based upon the echo only, we are measuring the distance. That I will explain in the theoretical part. This is what happens in this read ultrasonic distance function. all those things happens within this function, read ultrasonic distance. So this is a function, and this function is generated by this block, read ultrasonic distance sensor. And here is our program. This is the setup, and here it's the actual setup. We have started the serial begin by this block. When we place this block, the serial begin has started with 9600 baud rate, and this pin mode 8, that is the pin 8 is made as an output pin, as well as pin 9, both are made as the output pin. Both these pins are used to control our LEDs. And here we measure the distance. Distance is equal to 0.1723 into value read from that function, that is from the 7 and the 6th pin. So this 0.1723 is the half of 373 centimeters. That is 0.1723 centimeters is equal to, that is the half of the speed of light in centimeters. Half of the speed of light in centimeters. Actually, the speed of light in meters is equal to 453. Let me come to the is here. This 340. The speed of sound, not the light. The speed of sound is 340 meter per second. When we convert this into centimeter per microsecond, it becomes 0.034. When it is divided by 2, we get point. That is the value which we that is this 0.034 divided by 2. That give 0.0123 centimeters. Okay. Then this is the serial print. This is the command for serial print, which is generated by these two blocks. And here comes our condition. If distance is less than or equal to 15, digital 8, high, that is the 8 goes high and 9 goes low. And if it is greater than 15, that is the right goes low, as well as that is the 8 goes low as the 9 goes high. So this is the overall delay which we are given. This is also all about our program. Now we can come to the concluding session. So this is the overall working of the sensor. It transmits the signal. When the signal hits the object, it reflects back. This is the triggering signal given to the sensor. Once the triggering signal of 10 microsecond is given, 8 pulses with 40 kilohertz will be generated and sent to this air, and this signal will be reflected back, and based upon that the echo will be. This echo may range from 150 microseconds to 25 milliseconds. Okay, now we can see the demonstration which I have recorded earlier. You can see this LED is in red color now. So this is, I have placed a scale at 15, and this is the sensor. Now let me show. This is I am placing a box here within this range of 15, and it is taken away 15, it glows in green color. When it is brought near to 15, it glows in red color. See here. Okay. So when we are going for our, that is our robots, we will be measure the distance in from, that is the, I can conclude that also. That is, in the next class we will be going to, we are about to do an obstacle avoidance robot. This obstacle avoidance robot will see the obstacle in front of it, and based upon the distance in front of it, that is the distance between the obstacle and our robot, it will change its direction, move left or right or come back or whatever it may be. We can define all those things in the next class. Okay, so with this we are about to conclude our today's session. Okay, so thank you for your participation. So if you have any doubts, you can mail us, and we are ready to help you at any time. So those who are newcomers, you can use our website for our previous videos. So in our achieversvirtualunu.com, it's our website. And in that you go to the courses menu and you can find these things. That's Arduino as well as our Python programs. And here you can specifically go to this Arduino and you can find all those 5 previous videos. Arduino 1, 2, 3, 4, and 5. And the 6th video is of today's class. We'll be uploading it also by today night. Okay. So we are about to end our session. Thank you. Thank you everyone for your participation. So regarding doubts, you can mail us. And the next class we will be concluding our sessions. Okay. With next class, we'll be concluding with an obstacle avoidance robot. We'll be using all those things which you have studied till today. That is our Arduino board, breadboard, LEDs, and that is the ultrasonic sensor as well as motors also. Okay. So herewith I conclude the session. Thank you. Thank you once more. And thanks to every one of the participants. Thank you.